Okay, so I'm going to go over a couple of problems that are going to be really similar to what you guys are going to have on your worksheet. And so your worksheet looks very similar to this. Notice mine is ID2, yours is ID1. But I'm going to tell you a little bit about the setup, the way I set this up. Numbers 1, 2, and 3 are really similar. 4, 5, and 6 are really similar. And then 7 through 10 are really similar, right? And yours is set up the very same way. So I'm going to do one of each. So I'm going to do 1. A gardener has 6 identical looking tulip bulbs, of which each will produce a different color tulip. 3 of the colors are unknown. However, 1 will become white, 1 will become yellow, and 1 will become pink. She plants them arbitrarily in a row. When the flowers start to bloom, what is the probability that the yellow one is first in the row, the white one is second, and the pink one is at the end of the row? So this is a pretty straightforward problem. We don't really need to use combinations on it, although you can. I just think that overcomplicates it. So if we're planting 3 flowers, what's the probability that the yellow one is first? So I have 6 tulips, and I know one of them is going to be yellow. I know that the others aren't going to be yellow because it says they're each different. 3 of them, I don't know what they are, but that doesn't really matter. The white is second. So now that I've planted 1 that's yellow, I only have 5 left to choose from. So I have a probability of 1/5 that the second one is white, and pink being the last one, now I only have 4 to choose from. So 1/6 times 1/5 times 1/4 is 1 out of 120. And you can leave it like this as a fraction or convert it into a percent or a decimal. 0.0083 is your decimal. Okay, so 2 and 3 are really similar to that setup. So I'm going to go ahead on to 4. I'm going to do number 4. And you guys don't have this worksheet. These are not the same problems, but your worksheet is set up the same way. A basketball player has a 50% chance of making each free throw. What is the probability that the player makes exactly 4 out of 8 free throws? So we need to figure out, our probability is going to be the number of successes out of the total possible, right? So how many successful ways can we do this? So we're trying to figure out, a success would be making 4 exactly out of 8. So how many ways can we do 4 things out of 8 tries? So that's a combinations. So we're choosing 4 out of 8. And this is just a calculator part. And we get 70 ways. So there's 70 ways to do 4 things out of 8.
So hundreds of main office, so hundreds of main office.
Now I need to figure out the total number of possibilities, because there are other possibilities that exist. So we could miss all of them. We could make all of them. We could make 5. We could make 6, so on and so forth. So out of 8 things, our choices are either he makes it or he misses it. So I only have 2 choices. And for the second one, the first one doesn't affect it. So I still have 2 choices for my second one, for my third, for my 4th, 5th, 6th, 7th, 8th. So 2 to the 8th power is 256. So I have 70 successes out of 256 possible. 35 out of 128, or you can leave it as a decimal for a percent if you want. Okay, so like I said, 5 and 6 on your sheet are very similar, so I'm going to skip those. And then 7, 8, 9, and 10 are a little bit different. So I'm going to spend a little bit more time talking about those types. So these previous ones, like this one that I did here, this number 4, I want to point out to you guys that he's making exactly 4. Okay, so I'm not doing different things. It's a 50% chance so it either happens or it doesn't happen, and I'm only picking from, 4 out of the 8. Whereas on this problem, a jar contains 8 black buttons and 7 brown buttons. So already we can clearly see that it's not a 50-50 chance anymore because they're different. 8 black and 7 brown. If 7 buttons are picked at random, what is the probability that exactly 3 of them are black? So sometimes we'll have problems that'll say all of them are black. That's a different situation. When we want to know exactly 3 of them or exactly just a few, so these 4 types are just a slightly bit different. I want to make you aware to look out for those kinds. So let's figure out how many total options do we have? How many different ways can we combine 7 things? Because we're choosing 7 buttons. Out of how many total buttons? Well, I have 8 black and 7 brown, so I have 15 buttons altogether. So how many different ways can I choose 7 out of my 15? So altogether, I have 6,435 ways, total options, right? So this is going to be, like I showed you guys on this problem, our number of successes divided by our total. So this 6,435 is my total. So now we want to think about what success looks like. If I'm choosing 7 buttons, 1, 2, 3, 4, 5, 6, 7, and exactly 3 of them are black. We use BL for black. What do the other ones have to be? The other ones have to be brown. They can't be black. If I want exactly 3 black, the other 4 must be brown. The other 4 must be brown. So I need to think about how many ways of my 8 black buttons, how many ways can I possibly get 3 of those exactly? So I'm doing 8, choose 3. How many different ways can I arrange my 3 black ones? And that's 56 ways. And then how many different ways can I arrange or choose out of my 7 brown? How many can I choose 4? How many ways? I have 35 ways there. Now they could be all mixed up. I don't have to have 3 black in a row and 4 brown in a row. I could have black, brown, but they could be mixed up. So we want to think about if we're sort of pairing up all of our 56 possibilities with all 35 possibilities, how many possibilities is that altogether? Right, so if I'm doing each of these 56 things 35 times, I'm going to multiply those. So I get 1,960 ways to order these. Okay, now that's a ton. That's a lot of things. But if you think back to our example yesterday with 3 books, A, B, and C, we only had 60 there, right? So I have a lot more. We don't want to write these all out. So now I have 1,960 successes and 6,435 total. So I'm just going to come over here and write it in this little space. 1,960 out of 6,435, or 382 out of 1,287. Okay, so simplified fraction, decimal, percent, all of those are fine.